All right, we're now going to move on. We just talked a little bit about just some properties of gases and a little bit about temperature and pressure, but let's now move into condensed states of matter. So when we're talking about condensed states of matter, we're talking about solids and liquids. Obviously, the molecules, due to the kinetic molecular theory, are much more compact. They're still moving, but they're more or less kind of in I don't want to say locked positions, but rather in a regular arrangement, regular repeating pattern. So that's the kinetic molecular theory, of course, that deals with the movement of the molecules, talks about how in a solid they're kind of stuck and moving back and forth. A liquid, they can kind of move past each other, but they are still pretty tightly compacted. And then gases, of course, they're kind of bouncing out and they can free away from each other as easily as possible. I do want to mention also as condensed states of matter that there is an increased density. Obviously, there's more molecules in a certain area, so therefore there's an increased density. I want to now talk about bond types. Obviously, the bond types, the most important is, well, I thought I'd just throw these out here. Of course, these are the bonds, the James bonds. Not necessarily all of the bond types we're going to be talking about, but I certainly feel it's important to mention. We've got our three initial ones: Sean Connery, in the original for 007 for movies, George Lazenby, Roger Moore, and some of our more recent, Timothy Dalton, still back in the 80s, Pierce Brosnan, and then now Daniel Craig. Skyfall just came out. I haven't seen it yet, but I'm sure it's another fantastic Bond movie. Bond types. So ionic bonds are the strongest, and obviously substances that have ionic bonds, you should recognize that those are a loss and gain of electrons, which of course is something like NaCl, sodium, and chlorine. Sodium has lost an electron, chlorine has gained. So obviously sodium would lose one, chlorine gains it, and it's a very, very strong bond. These substances are very commonly, and again I should mention loss of gain, so that's a positive and negative. But I should mention that these substances are usually solids at room temperature. Because their bonds are so strong, it creates the fact that you have these positive negatives, the atoms are going to be, the molecules are going to be closer together, and therefore most ionically bonded substances are going to be solids at room temperature. The next type, metallic bonds. Metallic's a little bit, is something we're not going to talk a whole lot about. Metallic bonds is, you can view as a sea of free flowing electrons. So metallic bonds happen obviously in metals, but they're a sea of free-flowing electrons. So these electrons moving around. It allows for metals to be conductive in terms of electricity and or heat. So that's a metallic bond. We're going to really just gloss over it and not worry about it too much. The next type is our covalent bonds, and those are our weakest. Your covalent bonds, of course, are a sharing of electrons. And again, if I were to look at an example, hydrogen gas, H2, hydrogen obviously does not gain and lose when it gets together, but rather share electrons. And so therefore, it's the weakest and most commonly covalently bonded molecules are gases and or liquids at room temperature. So those are your different bond types. That's really just a beginning, but what we want to do is differentiate between bonds, which are the interactions between atoms in a molecule, and our next topic, which is intermolecular forces. Intermolecular forces are the forces between neighboring molecules. International travel is when you're traveling between one nation, one country, and another. Intermolecular are not the ones that are happening within one molecule. So like an H2O molecule, if you have H2O, this O with the two H's, and of course the unequal sharing. And the partial charges is an intramolecular. It's the stuff that's happening in a molecule. So this is not, this right here is not an intermolecular forces. Intermolecular forces are the forces that act between one water molecule and another molecule. We'll take a look at that in our next set of videos.